compositions of functions. This is where I take a function. If you see something that looks like fog, it actually says the composition of functions, which is the function of f of g of x. So it's where I plug this function into the other function. Okay, anywhere there's an x, I'm plugging the original function, the other function, into that x position. So if I have this and I want to figure out what the function of f of g is,
Man, this clue.
then that means I have the function of f of g of x. So I am plugging this equation in here to this x here. So you would get the square root of x minus 1. Okay? And in this case, you would leave it as the square root of x minus 1. Now, you do need a domain. Okay? To figure out the domain, I say x minus 1 equals 0, and I get x cannot equal 1 because I can't have a, it can't be less than 1 because I can't have a negative in there. Okay? So my domain comes out to be, okay, my domain comes out to be 1 to infinity because I can't go below 1, but I can go any positive number that way. So when you have a function that is in a square root function, you have to make sure that you include a domain with it. Same with if I have a fraction, I have to include a domain with it. From there, we get some more difficult compositions. We're going to look at 3 or 4 more. Okay. Let's say you have the function f of x equals x plus 2, and g of x equals 4 minus x squared. The first thing I want us to find is the function, the composition of f of g, which is the function of f of g of x. Okay, so I'm going to take the g equation, plug it in anywhere there is an x in the other equation. Okay, so when you do that, that means I take this right here, plug it into that x. So I get 4 minus x squared plus 2. Okay, from there, you're going to follow simple order of operations, combine like terms. So I have negative x squared plus 6. Now, what would be your domain on this? You don't have to include one, but what would be your domain? No, this,
isn't it like x plus 3x minus 1?
not on this one. This domain is all real numbers. I can literally plug anything into this function and get an output because I don't have a fraction and I don't have a radical. It doesn't matter what I plug in. Okay? The only time domain really matters is if I have a radical because I can't have negatives in my radical, and if I have a fraction because I can't have 0 as the denominator. Okay? Otherwise, my function's domain is going to be all real numbers. Okay? Let's say it says find g composition f, which means I'm finding g of f of x. What does that mean we're doing in this case? Plugging this in, okay, plugging this equation into that x, which means you get this, 4 minus parentheses x plus 2 squared. Okay, that square still has to go with that x. I literally took this whole equation, plugged it into that x, but I still have that square with it. What does the fog mean? That's what tells me I'm doing a composition. That actually says the composition of f of g. Yes, this little thing stands for composition. Composition, composition, composition. Okay, so from here, I have to factor first. So I have, technically, I have 4 minus x plus 2 times x plus 2. X times x is x squared. 2x and 2x is 4x, and then I get plus 4. Then I have to distribute that negative so that you get 4 minus x squared minus 4x minus 4. That means these cancel. and you are left with negative x squared minus 4x. So when you're doing compositions, you have to take it all the way down to the final possibilities. Let's say it says find the domain of this composite function. And the function says f of x equals x squared minus 9. And then it says g of x equals the square root of 9 minus x squared. They want us to find the domain of this composition. And the composition they want us to find is the composition of f of g. So the function of f of g of x, which means what am I doing? Plugging in the g to the x on the other side. So I'm plugging this in to this x. So you get the square root of 9 minus x squared squared minus 9. What happens to that function? The square goes away, and you're left with 9 minus x squared minus 9, which means these cancel, and you're left with x squared. Now, here's how you find the domain of this. You need to figure out what is the domain of this function. What is the domain of the function f of x, x squared minus 9? What is the domain of that function? It is. It's all real numbers, Lindsay. Okay, so this is all real numbers, which means it has no stipulations. So my domain is going to be determined by this function over here. So I have to find the domain of the square root of 9 minus x squared. What is the domain of 9 minus x squared? Plus or minus 3. Good. It's plus or minus 3. So your domain of this function comes down to that. Your domain is negative 3 to 3. Because this is a difference of squares, which means you have 9 minus x squared, which breaks down into 3 minus x and 3 plus x. So when I set those equal to 0, I get x equals negative 3, or I get x equals positive 3 or negative 3, which is where I get my domain. So when they're asking you to find the domain of a composite function, you take the domain of each function separately, and whichever one has a smaller range is the domain of your overall. That's the easiest way to find it. Okay.
I got a question.
Yes.
Alright, back to the area where I asked the log is, so you did all the steps, what's the answer to? Like, I know it's negative.
Just negative x squared minus 4x.
Plus 16, is that just like, are you just simplifying it?
You mean right here, negative x squared plus 6? Yeah, you're just simplifying it. That's as far as you can take it.
And the other one's just numerator.
Mm-hmm. Yep. What, Matthew? Yep.
What?
Okay. And then the last thing we need to look at is what happens if a function of a function equals itself. So what happens if they want us to prove that f composition g equals g composition f? Okay? And they tell us that f of x equals 2x plus 3 and g of x equals a half x minus 3. If each composition, okay, if each composition equals the same thing, if I do the composition of f of g and I do the composition of g of f, if both of them equal x, then I know they are inverse functions of each other. So I have to start by seeing if the first one equals x. So does f composition g equal x? Does f of g of x come out to equal x? So I'm taking this equation and I am plugging it in to that x. You have 2 times 1/2 x minus 3 plus 3. So what I automatically know is that 1/2 and 2 will cancel each other out, giving me x minus 3 plus 3. This then cancels out and you are left with x. That composition right there equals x. If the composition of g of f of x equals x, then they are inverse functions of each other, and that's important to know because when we go to graph things or whatever, it will be the opposite of what the other is. So I then have to find g composition of f, which is the same as g of f of x. And I'm taking this equation now and plugging it into that x. So you get 1/2 of 2x plus 3 minus 3. 2 times 1/2 cancels again, giving me x plus 3 minus 3. They cancel, I get x. Those are inverse functions of each other. F composition g and g composition of f in this case are inverse functions. So what you are going to be doing tonight is finding domains of composition functions and setting up and reducing compositions of functions completely. And then proving if compositions of functions.
Like, you moving too fast. I just finished writing down the green.